Hi there, welcome back to Unlock Your Knowledge Needs. So today we will be discussing about mesh analysis, one of the basic analytic technique that is used in network theory in order to calculate the individual mesh currents. Alright, what do we mean by a mesh? A mesh, which means that a closed path where the current circulates and it doesn't have any other sub loops. It can have one loop inside which the current is flowing and it cannot create no other subloops within it. Then we call that as a mesh. Okay, according to the given problem here, we have three meshes. So mesh 1, 2 and 3. So we will be having three currents I1, I2 and I3. So I'm considering that all the currents are flowing in clockwise direction. Okay, so now we have identified the total number of meshes and we have assigned the current direction for each mesh. Now we can write the mesh equations. So as we have three meshes here in this problem, we will be having three mesh equations. Alright, now let us start writing the first mesh equation. So for mesh 1, right, for the mesh 1, let us assume the directions or let us assign the directions for the components that are available with individual mesh. So now for mesh 1 we are writing the mesh equation 1. So the power source, there will be no changes. Accordingly we will be providing positive and negative. And two resistors, these are power absorbing components, so their direction will be opposite to the current's flow. So we will be providing positive, negative, positive and negative. Right, so now let us start writing the equation from the source direction. So we have one source. This source, the current is flowing from negative to positive, so we write it as plus 5 volt plus, or we can write plus 5 volt for source. Second source, here the current is entering the positive terminal and leaving the negative terminal, which means that it is going to be minus 2 volt, and there are no more sources, and so we can write equal to, and we have two resistors where each resistors are being shared with another mesh. So let us write the corresponding mesh resistance first. So accordingly we will be having I1's sharing, so we can write it as 2k I1 plus 1k I1. So no more components that is owned by mesh 1. Now the component that is shared with mesh 2, so this component is shared with mesh 2. So we can write the corresponding sharing value. So what is the direction of the current I2 that is flowing through R? The current direction is from negative to positive. The current is leaving the positive terminal. So according to current 2, it is a voltage raise, and therefore we will write it as minus 2k I2. Similarly, for I3, we can see that the current is entering the negative of R3 and leaving the positive of R3. Again, the voltage across R3 becomes a potential raise, and therefore again we put it as minus 1k I3. So rearranging and rewriting the equation, we can write it as 3 is equal to 2 plus 1, 3k I1 minus 2k I2 minus 1k I3. So this equation governs for mesh 1. Now writing for mesh 2, writing the mesh for mesh 2. So now we can erase all these because these are related to mesh 1. Okay, so components again minus, plus, and here it will be positive, negative, positive, negative, positive, negative. Okay, so with respect to I2, the source is having a potential raising direction. It is entering to the negative and leaving the positive. So we can write it as 2 volt is equal to, as there is no more sources, we can put it as equal to, and on the other side we will be writing the power or potential dropping component values with respect to I2. So potential dropping components with respect to I2 are 1k, 2k and 2k. So we can write it as 2k plus or 2k I2 plus 2k I2 plus 1k I2. So that's all. We have 3 resistors for I2 and we have 2 resistors that is being shared with the other meshes. So correspondingly we can write for mesh 2 and 1. So let us see the direction of mesh 1. So the mesh 1 current is flowing through R1 in the opposite direction corresponding to the mesh 2. Opposite in direction corresponding to mesh 2. This is flowing from negative to positive and therefore it is considered as a potential raise. But we are writing it on the potential drop direction. So we will write it as minus 2k I1. Similarly, the current direction of I3 is from negative to positive of R4. So we can write it as minus 2k I3. So rewriting all the equation, this mesh 2 equation, we will be writing it as 2 is equal to minus 2k I1 minus, sorry, plus 2 plus 2 plus 1, 5k I2 minus 2k I3. Similarly for mesh 3. So now erasing all the components with respect to mesh 2. Let us assign direction for mesh 3. So positive, negative being source, that is standard. For the components, we will be giving the direction as positive, negative, positive, negative. Alright. So let us start from the source. The source, we can see that the current is entering into the positive and leaving the negative. So we will put it as minus 3 volt is equal to the voltage dropping values. So voltage dropping is 1k I3 plus 2k I3. So the remaining are sharing elements. So R3 is shared with mesh 1 and R4 is shared with mesh 2. And we can see the direction of current in direction of current from mesh 1 in R3 is from negative to positive, and therefore that will be a voltage raising component. And writing it on the voltage dropping side, we will write it as minus 1k I1. Similarly, we can see that I2 is from negative to positive on R4. So again we will write it as minus 2k I2. So rearranging the equation, we can write it as minus 3 is equal to minus 1k I1 minus 2k I2 plus 1 2 is 3k I3. So this is going to be equation 2 and 3. Now substituting all these three equations and solving it with the simultaneous equation method, we will be able to get our solution. So let us rewrite all the equations. So it is first equation is 3k I1 minus 2k I2 minus 1k I3 is equal to 3. Second equation is minus 2k I1 plus 5k I2 minus 2k I3 is equal to 2, and minus 1k I1 minus 2k I2 plus 3k I3 is equal to minus 3. So solving these three equations, we will be able to get the corresponding answer. So your I1 is equal to 2 milliamps, I2 is equal to 1.25 milliamps, and I3 is equal to I1 is equal to 2. I3 is equal to 2.75 milliamps. I2 is equal to 2 milliamps, and I3 is equal to 1.25 milliamps. Okay, I hope you understand the technique and the method how we will be solving a mesh analysis. It's pretty easy and simple. So if you have any clarifications with any other problems that you feel that is complex with mesh analysis, kindly share that in the chat box or with the comment so that the solution of the same problem will be shared with you. Thank you. All the best.